It's a very good question. Sine has this graph, and it repeats indefinitely on both sides. This sine is not one-to-one, right? By the horizontal line test is not one-to-one, so it doesn't have an inverse. Not so fast. So we said that if we define sine between negative pi over 2 and pi over 2 with a range, so this is domain, which is false. Sine is defined everywhere. But if we restrict the domain to negative pi over 2, and the range will be negative 1 to 1, the function now, just for this purpose, will look like this. Between negative pi over 2 and pi over 2. For that reason, there is only one possibility, one and only one, for arcsine to be 1/2. Is that okay?
Yeah, so there does not need to be bounds specified in the problem.
There is only one answer. One possible answer here. So arcsine is defined on negative 1, 1, taking values between negative pi over 2 to pi over 2. Only one value will work. So you don't have to specify anything, because we know that sine has to be defined like this in order to find the inverse.
Okay.
So that is carved in stone, and it's carved in stone for cosine, for tangent, for secant, cosecant. These are carved in stone.
Okay.
Good enough?
Yeah.
Excellent. Very good question. Very good question. Thank you. Perfect. Next question.
I have a WebAssign question.
Yes. I will.
5.2,
Yes.
number 4.
Yes, anything. So let me, where's my keyboard for this computer? So let me log in. I'm going to go directly to your problem because, as you know, I'll get something else if I go for myself. Okay, and Ken, where do I look? Which section? I'm sorry, Kenny, I didn't hear you. What section?
Oh yeah, sorry. 5.2, number 4.
Okay. 5.2, number 4. Let's take a look. Number 1, 2, 3, 4. Okay. So we have used the midpoint rule, and it's the integral from 0 to 40 from sine the square root of x dx with n equals 4. Perfect. Excellent. And they want us to approximate, right? I see the answer you entered. So somehow you just missed a tenth. So you were on the right track. So something went wrong. We can do it together.
Okay.
So 0 to 40. 10, 20, 30. 5, 15, 25, 35. So this will be approximately, so the integral from 0 to 40 from sine the square root of x dx will be approximately base times height. So the base is 10. I'm going to put it out. So this is sine of the square root of 5 plus sine of the square root of 15 plus sine of the square root of 25 plus sine of the square root of 35. So I recommend this method, and let me show it again. So go to Stat and edit a list. If you have anything in the list, just clear it. I worked with my stats class this morning with those two lists. So in list L1, I will put 5, 15, 25, 35. 5, 15, 25, 35. Then I go to list L2, but highlight the name of the list. And once you highlight it, just put 10 multiplied by sine the square root and put list L1. Don't forget to come out of the square root and close the parenthesis. Assuming that I did not change my mode, I think I didn't. It's in radian mode. I'll check. Press enter. And you will get all these numbers. You will get 10 times this, 10 times this, 10 times this, and 10 times this already in the second column. So let me check my mode. It is in radian. Let me check my list. 5, 15, 25, 35. Okay. I don't like the numbers I'm getting. That's why I'm checking. I don't know the answer, but I don't like what I see. Sine. So let me just make sure that I have 10 multiplied by sine. And it is the square root, right? Yes, it is a square root. Square root of list L1. Close. Okay, some of them are negative. We'll see in a moment. So now I go back to second and calc, and I do one variable stats on list L2. And I'm interested in the sum. Okay, so they say round your answer to 4 decimal places. So this is what I got. Negative, this is the sum right here. Negative 11.9899573. I don't need all those. And they send again 4 decimal places. 1, 2, 3, 4. Because this is 5, I have to round this to 0, 0, 9. So then it's approximately negative 11.99. If you want to put the other zeros, fine. If you don't want to put the zeros, fine too. So everything was correct. I just thought that I was expecting different numbers. I don't know why in my mind. So, but everything is correct. So I think that this is the easiest method if you have a different method. So this is from statistics, but it will give you the sum. So it gives you the mean, which you don't care, and all the other things that we use in the stats class. But all I need is the sum. It gives me the sum without me calculating or adding anything. This is so easy to make mistakes. Perfect question. Anything else you would like to go back to? Anything else? You don't have to redo that problem. I will add the points for you.
Okay, thank you.
Yeah.
Same section, number 16.
Let's look at number 16. 10, 11, 12, 13, 14, 15, 16. Okay. What are we trying to do? Okay, use this property to estimate the value of the integral. Okay. So we have, this is the integral from, you do have pi over 8 to pi over 6, correct?
Yes.
from 7 tangent to x dx. Okay, so first of all, I look at the graph of tangent. Tangent of x or 2x, not a big deal. So obviously this is the first quadrant. So this is pi over 8 and this is pi over 6. So these are in ascending order. And I know that the tangent looks like this. So it's very important to know that, because if you remember, cosine is a decreasing function. Then the signs of the inequality will change, right? But tangent is an increasing function. So remember how I start. I have to start here. This is what I know so far. That x is between pi over 8 and pi over 6. Then I have to make sure that the function is increasing, because if the function is increasing, then tangent of this must be less than tangent of this, which must be less than, of course, or equal to tangent of this. Okay, so that's the first step. Once I establish this and the fact that the function is increasing on this interval, I don't care anywhere else. It's always increasing, but all I care about is between pi over 8 and pi over 6, if it is increasing. And it is. So then tangent pi over 8 less than or equal to tangent x, which is less than or equal to tangent pi over 6. Is this okay so far?
Yes.
Okay. Now you can say, but what about twice x? Yes. Let's do the twice x before so this was just to show you that the function is increasing, but I'm interested in twice x. So 2 times this, pi over 4, less than or equal to 2x, less than or equal to 2 times this, which is pi over 3. Because I have twice x. So this is good, but that's not what I need. So then tangent pi over 4, less than or equal to tangent twice x, less than or equal to tangent pi over 3. And in order to finish up the function, I have to multiply all 3 sides by 7. I have to have everything that I see here in the middle. So I'm multiplying all 3 sides by 7. So I get 7 tangent pi over 4 less than or equal to 7 tangent twice x less than or equal to 7 tangent pi over 3. So far so good. Any questions?
Yeah, that's good.
Okay, so I know the tangent pi over 4 is 1, so this is 7. I know the tangent pi over 3, remember this is the big angle, so sine of pi over 3 is the square root of 3 over 2, and cosine is 1/2. So when I divide those, I get 7 the square root of 3. So far so good?
Yep.
This is the property that says that if a function has a lower bound and an upper bound, then the integral of this must be less than or equal to the integral from this, must be less than or equal to the integral from this. Of course, from pi over 8 to pi over 6, because that's what we're trying to find. Pi over 8 to pi over 6. Do not forget the x. The integral makes no sense without the x. Okay, so the middle is clear. I need to calculate this. So this is 7x from pi over 8 to pi over 6. And this is 7 the square root of 3x from pi over 8 to pi over 6. That's what happens when you don't plan ahead. So learn from me and plan ahead. From my mistakes, I meant to say. Okay, so 7, I plug in pi over 6, and I subtract pi over 8. Seven the square root of 3, same thing. pi over 6 minus pi over 8. And now let's see what they want. They want, they don't say anything about any approximation, so we have to give the exact answer. Okay, so the least common denominator is 24. This needs a 4, this needs a 3, so that's pi. And less than or equal to, less than or equal to the same thing, 7 the square root of 3, and it's still pi over 24. So I would enter 7 pi over 24 for the lower bound, smaller value, and I will enter 7 pi the square root of 3 over 24. Seven pi square root of 3 over 24. Very good question. Thank you. Good pick.